Hey everyone, this week, this little lesson is going to be just about growth and decay, and this will wrap up the rest of our unit. So I'm just going to start off by just doing a quick review or discussion about converting percents to decimals. We're gonna do that often here. So what I like to do when I talk about this is I like to break down this word percent. Okay, per means to divide, like miles per hour is dividing by hours, or figuring out how many pieces of candy per person you divide by number of people, right? And then cent is 100, like that's French for, cent is spelt like that, is French for 100. And also think of 100 cents in a dollar as well. So converting percents to decimal, you divide by 100. That's what percent means. I'm going to show just a few quick examples, like 26%. We would do 26 divided by 100 and gets us 0.26, okay? Now, I know some of you might say, well, I know I just moved that decimal back twice. And that's okay. You can do it like that, but I see a lot of mistakes, and specifically ones like this, like 5%. Okay? If we do 5 divided by 100, that would be 0.05. Okay, a lot of times people forget that 0. And if you were to put 0.5, that's actually 50%. So it's not the same as 5%, okay? So I just divide by 100. It's a lot easier that way. Let's do 7.2%. Would be 7.2 divided by 100, which is 0.072. Okay? Just a few quick examples. Like I said, we're going to do that kind of over and over here once we talk about growth and decay. A lot to do with percentages. So growth, I just want to write some keywords to look out for, like gains, increases. We could say goes up. Earns, like when you earn something, that's going to go up as well. And I'm sure there's a lot more that you might see. For decay, it's going to be like depreciate. That's one. We'll see depreciation. Okay, goes down. Decreases. And again, there's probably many more. Here, I want to write the formula for us, and leave some room above and below, because we're going to write what each letter represents. And some of you may be pretty familiar with this formula. It's just a growth and decay, like a basic growth and decay formula. Notice that the plus, that's if it's growth. So if you know that it's growth, then you're using 1 plus. If you know that it's decay, then you're doing 1 minus. Okay, and then what we were adding or subtracting are, that's your rate, and I'm going to put as a decimal. So remember to divide that by 100 to get that decimal. Let's say if we had 4.2%, okay? If it was growth, it'd be 1 plus, well, that'd be 0.042. So it'd be 1 plus 0.042, or if it was decay, it would be 1 minus 0.042, okay? So we'll take a look at a few of those. Coming up here, T, that's time. Typically it's in years. We'll see some examples of where it's not, but usually you'll see that in years. Doesn't really matter for that though. P stands for principal. Not like Principal Pickens, like principal, like how much money you start with, okay? So I'm going to put your start. That's like a word that we'll look for, initial. And I'm going to put A sub 0. Because remember, we had to go backwards sometimes to find that 0 term. That is your principal. It's the same exact thing, okay? A, that's just like your end amount. It's like your y equals, you know. So that's kind of what we got there. All right, let's do a couple examples to kind of help us out, kind of get it going, okay? If you want, pause it right now and make sure you get all this info down, or take a screenshot of it or something like that. But you can pause it and then play it. Hit play as we move on. John put $5,000 into a bank account that earns, okay, that's a key word right there. That means it's going to be 1 plus the 5.3%. So there's two things that I like to do. I like to determine if it's 1 plus or 1 minus, and then I like to figure out my decimal. Just like that, 0.053 divided by 100. How much after the first year? Well, just plug it in. 1 plus, because it's earns, 0.053, and then I can do to the power of 1. I don't have to do to the power of 1, but power of 1 will just keep it the same anyway. I get $5,265 after just 1 year. So to get the second year, I could just do 5,000, 1 plus to the power of 2. That one you do have to plug in. So 5,000, 1 plus 0.053 to the power of 2. I get $5,544.05. Okay. Now, all this is a geometric sequence. This is your a sub 0, and this is like your x to the power of x. That's your term number. We just found the first term, the second term, and now I want you to find the 10th term. Okay. That's all this is. It's the same, same as kind of what we were doing with geometric sequences. Okay. So to find the 10th term, or how many after 10 years, 1 plus 0.053 to the power of 10. Okay. And I get $8,380.19. It's 0.187, so I round that up to 19. Okay. So just kind of using that formula, determining if it's 1 plus 1 minus, convert that percent, and then plug and chug. So here, you buy a car for $8,000, it decreases. There's 1 minus. 30% would be 30 over 100, which would be 0.30. And we're doing the same thing that we kind of did above, 8,000, but now this is 1 minus 0.30 to the power of 1. Again, you don't have to do it. I'm just going to write all of these down because, like I said, they're all pretty similar, and then I'll type them all in. That would be to the power of 2. And this one would be to the power of 8. Okay. Now, this is what I'd like you to do. I'd like you to pause it and plug these in yourself. And then once you hit play, you'll see all the answers go on, right? So I'll just kind of write them down quick. So once you pause it, try plugging in each of these on your own and then double check that we get the same thing. Okay. So hopefully now you're coming back from the pause. But who knows if you actually listen to me. This first one's 5,600 when I plug it in. The second one is 3,920. So it's going down quite a bit, right? Now, after 8 years, this car is only going to be worth $461.18. Pretty crazy. After 8 years, it decreases that much. Is it realistic? I don't really know. I'll be honest with you, I'm not sure. I think it changes, depends on the car, all that stuff. But either way, cars do decrease quite a bit. Okay. This last one here. Again, if you think I'm moving too fast, you have the power to pause me. You can shut me up. Starts with 45 bacteria. Increase is that 1 plus, and then the 75% I divide it by 100. 0.75. We want to know how many bacteria will there be after 2 weeks. That's 14 days. And so that's where like the T The T kind of depends. So here above it says it increases by 75% every day. That's why we have to convert that to days down here. Okay, so 45, we said it was 1 plus 0.75, and then be to the power of 14. Again, practice plugging that in. Don't just write it down, because you will eventually have to do this on your own. Okay, I get 113,696 bacteria. Okay, awesome. Well, we have one more kind of piece that we're gonna talk about, and it's called compound interest. Now this compound interest, there's a new, sorry, I think I actually muted myself. There's a new formula for this. It starts out pretty similar. We're only gonna do plus for this one. R over K, that's a letter K. I'm sorry, I'm gonna do to the power of K times T. So this K value that we have now, that's the only thing that's different. Compound interest is typically what we see with like loans, mortgages, kind of all that stuff. For this, K is going to be equal to 12 because we're going to have our compounding period be monthly. So typically your interest is compounded monthly. It's not just applied at the end of every year, it's applied at the end of every month. And that's what this means down here, if we see it in this word problem below, the compounded monthly. So for this course, just for this trimester, we're just gonna do monthly. We may get into like yearly, which would be 365. Daily would be 365. Quarterly would be 4, and so on. So like I said, we're just gonna stick with monthly. So K is always gonna be 12 in those, okay, in this formula. So Javian took out a loan for $5,000, annual interest rate of 5.5%. So that 5.5 divided by 100 is going to be 0.055. That's our rate. So the reason why we will divide that by 12 is, like I said, because it's compounded monthly. But it's because that interest rate is an annual rate. So what we do is we break it apart into each month. Like we put a little piece of it into each month. That's why we have to divide it by 12. And then when we do to the power of 12 times 3, that's because it's going to happen every single month for 3 years. So it's going to be 36 times, but I like to just do it as 12 times 3 in the top. Okay, this one for sure, I would pause me and make sure you're plugging it in correctly, especially if you're using like a scientific calculator or something like that. You'll want to make sure you do all the parentheses and everything. Now this parenthesis right here is also important if you're using Desmos or something else. Make sure you just group that as that in parentheses there. Okay, so give it a shot, take your time, plug it in the right way. And then you should have gotten 5,894.74 after 3 years. Okay. Awesome. I'll move on. I think there's just one more, and then I'll talk about a little project here. And I might make a new video for that anyway. So here it says Rachel took out $6,500 for her first year in college. The annual interest rate is 6.25% compounded monthly. That means we have to divide it by 12. How much will the loan be worth? That should be worth after 4 years. So we're starting with the $6,500. 1 plus 0.0625. I divided that by 100 to get that. Low-key. 12 times, we want 4 years, right? There we go. Okay, and we just can plug that in. Again, just being careful with how you're doing it. Pause me, try it on your own, and then double check that you get the same thing. Okay, just copy it down because you're gonna do these a bunch in a little bit. equals 8340.75. So that's crazy. Rachel took out a $6,500 loan. After 4 years, now she owes $8,300, over $8,300. That's a lot of money that she's like having to pay back. And this is going to be our next part. So there's going to be a part 2 of this video about the student loan project. So make sure you watch that. That's going to be a quiz score, just out of 5 points. It shouldn't be anything too crazy. So just take an eye, or I say keep an ear out for that. Watch that video. For the homework, there's just 3 problems on the back of this, and actually number 3, I totally messed up. So I'm just going to have you skip number 3. If you can please write skip on that problem, so that I just kind of know that you've watched the video and all that too. Awesome. Well, thank you. Yeah, like I said, stay tuned for that student loan video coming up next.